Hello everyone, in this video we're going to learn how to identify the inverse of exponential functions. Actually, the inverse of exponential functions are logarithmic functions. Alright, so first we need to know how to identify the exponential functions and logarithmic functions given the tables. Alright, so in order to identify the exponential functions, we're going to look at the input and output. If the input values are changing additively, while the output values average changing multiplicatively, and then that is the exponential functions. Conversely, if the input values s are changing multiplicatively, the output values average are changing additively, which means equally spaced, and then that is logarithmic functions. Now let's take a look at the few examples. Now let's take a look at the first one. You see that the s value increasing by 1 each times. The y values multiply by 1/2 each times. So based on the definition of exponential function right here, this is actually the exponential function. Alright, let's take a look at the second one right here. We see that the s values multiply by 2 each times to get the next value, right? The y values increasing by 5 each times, which means you're gonna add 5 each time to get the next value. So this is the logarithmic function. Now let's take a look at the third one right here. We see that the s values multiply by 10 each times to get the next value. The y values multiply by 3 each times to get the next values. So this is neither. Now the last one. The s values multiply by 3 each times to get the next value, right? The y values add in -5 each times to get the next value, right? So this is the logarithmic function. Now let's move on to the next example. Given two functions f of s equals 5 to the s and the function g of s equals log base 5 of s, we need to prove that two functions right here are inverse of each other. So based on the properties right here, we need to prove this one. Okay, so keep in mind the base of the exponential function right here must be the same as the base of the logarithmic function right here. So they are inverse of each other. Keep that in mind when you do the multiple choice questions. Alright, so look at this one. So I'm going to start from here first. So I'm going to start from f of g of s. Alright, so this one the same thing as f of g of s equals log base 5 of s. So I just put this guy inside parentheses. Log base 5 of s. Now this one is the same thing as, now I look at the function f of s, it's going to be right here. So I just rewrite 5 right here, right? Now you see that this is s, this is s. Now this is log base 5 of s, and then this guy must be log base 5 of s. Alright? Now we learned before, we know that a to the log base a of s equals s. Keep that in mind. This guy right here and this guy right here must be the same to apply this formula. Alright, so this guy equals ask, right? Because phi and phi right here should be the same. So I just prove the first guy right here. This guy equals this guy. Now I need to prove the second one. So I start from g of f of s right here equals g of, I'm gonna replace f of s with phi to the s right here. So I put phi to the s. Alright, so the function g is gonna be right here. So I just rewrite log base phi right here. Now you look at this one, this is s, this is s. Now this is phi to the s. This guy must be phi to the s. Alright, again, you learned before, if you have log base a of a to the s, alright, so you just print s to the front. So it's gonna be s log base a of a. But log base a of a right here equal to 1. So the answer is s times 1, which means s. Alright, so based on this formula right here, phi and phi right here should be the same, right? So the answer must be s. Now, since this guy equal s, this guy equal s, so I can conclude that f of g of s equals g of f of s equals s. So the function f of s and g of s are inverse of each other. Now let's move on to the next example. So suppose I have the function y equals phi to the s, and I'm going to ask you to sketch the inverse of this function. Alright, so based on the property of the inverse of the function f and f inverse, the line y equals s is an axis of symmetry of inverse functions. Alright, and if the point A and B belong to the graph y equals phi to the s, and then the point BA will belong to the inverse function of this function. Alright, so the first thing I need to do is I need to sketch the axis of symmetry. So the axis of symmetry is y equals s passing origin and split the first quadrant and the third quadrant in half. So it's gonna be something like this. Alright, next one, I need to find the point on the original function. So you see that the y-intercept of this function is going to be 0, 1. And then the point on the inverse function should be 1, 0, right? So it's going to be right here. Alright, next one, I need to find another point. So the point's right here, I get this one right here. It's going to be 1, 5. And then it turns out to be 5, 1. So it's going to be right here. Now I just sketch the rough draft of this inverse function. Alright, so what do you learn from the original and the inverse functions? Now the first thing I learned, the y-intercept of this function, it's gonna be 0, 1. This one becomes the x-intercept of these logarithmic functions, which means s-intercept is gonna be 1, 0. Now the second things I learned is the asymptotes of this function, which means the x-axis right here. Do you see that? Right? The equation of the x-axis is y equal to 0. So you need to know these terminologies right here, just in case you see this one on the exam. You should be able to identify the correct answers. Alright, the asymptotes of this guy is y-axis, which means s equal to 0. Now the third one I learned is the limit of this function. Alright, the limit of the function, I call this one is f of s, and I call this one is g of s. So the limit of the function f of s when s approaches positive infinity equals, you see that s approaches positive infinity, right? This one is positive infinity, this is positive infinity, this is negative infinity, and this one is negative infinity. Alright, so when s approaches positive infinity, which means s goes to the right, the function keeps going up forever. You see that? Alright, so it's going to be positive infinity. Now, limit of the function f of s when s approaches negative infinity. Right? Look, when s approaches negative infinity, which means s going further to the left, the function approaches 0 because it's getting closer to the s-axis. So this one should be equal to 0. Now for this function, the limit of the function g of s when s approaches positive infinity is going to be positive infinity, because when s approaches positive infinity, the function is going up, right? So it's going to positive infinity. Now, limit of the function g of s when s approaches 0, right? Not negative infinity, it's 0 right here, because the function can't pass the y-axis, right? So the function g of s approaches negative infinity because it's going down right here. You see that? Alright. Now, number 4. The function f of s is concave up or concave down. Alright. So when the function is concave up, it should be something like this. Alright. Or half of this one, which means you're gonna cut this one in half. So it turns out to be something like this or something like this. The function is concave down, it's gonna be something like this. Or when you cut this one in half, it should be something like this or like this. Alright, so we look at this one, we see that the function is concave up, right? So this is concave up. Now we look at this one right here, it should be something like this right here, right? So the function is concave down. Alright, next one. The function is increasing or decreasing, right? So we look at the rate of change. In order to do that, we just sketch the tangent line. Okay, so keep that in mind. Now, here's the trick. Keep in mind, we have the Christmas tree trick. Alright, if the lines go this way, right, go up this way, the slope is positive. If the line goes this way, the slope is negative. Alright, if the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Look at this line right here. The lines go this way, the slope is positive. And if the line is steeper, the slope is bigger. Conversely, if the line goes this way, and then if the line is steeper, the slope is smaller. Now, based on this instruction, we're going to explore the function f of s and g of s to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so we look at the function f of s right here. We just draw a tangent line. So we see that the tangent line of the functions go this way, which means the slope is positive, so the function is increasing. Alright, now we're going to see if the function increasing at an increasing rate or decreasing rate. So we keep drawing tangent line, and we see that the tangent line is getting steeper and steeper, which means the slope is bigger and bigger. So the function is increasing at an increasing rate. Now we look at the right hand side right here, the function g of s. Alright, so we still draw the tangent line, and we see that the tangent line still go this way, so the function is increasing. Now the function is increasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that if we draw the tangent line right here, we see that this guy right here is steeper than this guy, and then we see that the line is getting less steep, right? Then the function is increasing at a decreasing rate. Now let's move on to the next question. Now I still use this graph, and if the questions ask you to approximate the value of log base 5 of 2 using this graph right here. Alright, so we look at this one right here. The formula is going to be log base 5 of s right here, and then we need to approximate the value of log base 5 of 2. Alright, so which means s right here equals 2. Alright, so we look at this one, and then the function g of s, which means the log base 5 of s right here. So we're going to use this guy right here, right? We use the function g of s right here. Alright, so s equal to right here, and then I project down to the x-axis and the y-axis right here. And I see is that the function log base 5 of s when s equal to is going to be approximately 0.4. Now let's move on to the next example. Given the function k of s equals a to the s, passing 2, 3, and 6, 27. We need to find the average rate of change of the function m of s equals log base 8 of s on this interval 3, 27. Now first we observe that this guy's the base is a, this is a, and this is s, which means the function k of s and m of s are inverse of each other. So since two functions are inverse of each other, the domain of this function will become the range of the other function. So this guy right here, the function log base a of s right here, will pass the point. This is 2, 3. This turns out to be 3, 2. Alright. This guy 6, 27 turns out to be 27, 6. Right? Alright. So we have the formula of the rate of change is going to be f of b minus f of a over b minus a. Alright, so we look at this one right here. This guy right here is a, f of a. This is b, and then this is f of b. In this situation, it's going to be m, right? Right here, the function m. So we just replace f right here with m. Alright, so keep that in mind, the function m. So we have m of b minus m of a over b minus a. And we just plug it in. M of b right here equals 6 minus m of a, which means 2, over b, which means 27, a, which means 3. Alright, we just simplify this one. 6 minus 2 is going to be 4. 27 minus 3 is going to be 24. And we simplify this one, it turns out to be 1, 6. Alright, so let's move on to the next example. Given the function f of s equals 2 times log base 2 of s, and the function g of s equals 2 power of 2 of s. Now, we need to determine if the function f of s and g of s are inverse of each other. Alright, so in order to do that, we need to use the formula right here. Alright, so first I'm going to start from f of s of f of g of s, right? It's going to be the same thing as 2 times log base 2 of s. But in this situation, s should be g of s, right? So I put parentheses right here. 2 power of 2 of s. Now we apply the formula right here. Alright, for this one. So it turns out to be 2 times 2s. It's going to be 4s. Alright, the bottom one right here, we're going to have g of f of s. It's going to be 2 to the 2. Now we need to replace s with f of s, which means this guy's multiplied by 2 log base 2 of s, right? So we're going to simplify this one. So it turns out to be 2 to the 4 log base 2 of s. And then I apply the formula right here. Alright, I can print k back over here. Alright, so I have 2 power of log base 2 of s, and then power of 4 right here. And then I'm going to apply the formula right here, the first formula. And then the answer must be s power of 4. Now we look at this one right here. This is 4s and this is s power of 4. They are not the same and they not equals s right here. And then the function f of s and g of s are not inverse of each other. Now let's move on to the next example. So I have the function f of s equals 10 to the 0.25s and g of s equals 4 log s, right? I need to determine that if f of s and g of s are inverse of each other. Alright, so I'm going to start with f of g of s equals 10 to the 0.25. Now s value right here, I need to replace with 4 log s, right? So it's going to be multiplied by 4 log s. Alright, now I need to simplify this one. So it turns out to be 0.25 times 4, which means 1, right? So I have 10 to the log s. Alright, so I know that if I just write log, which means log base 10. So I just rewrite this one as 10 log base 10 of s. So I look at this one, this guy, the same thing right here. I apply the first formula right here. So the answer must be s. Alright, now let's move on to the next one. G of f of s equals the function g right here. It's going to be 4 log s, but s equals f of s, right? So I just replace s right here with 10 to the 0.25 s. Alright, so this guy turns out to be 4 log right here. There is no base, which means base 10, right? So I just write log base 10 of 10 to the 0.25 s, right? Alright, so I'm going to apply the formula right here. Alright, so the answer for this guy right here equals 4 times 0.25 s, right? And then this guy equals s, right? Because 4 times 0.25 equals 1. So both of them equals s. So then this guy and this guy right here are inverse of each other. Now let's move on to the next example. We need to find the inverse of this function. Alright, so this is the exponential functions. So by the definition right here, the inverse of this function must be the logarithmic function, right? So our goal is we need to find the inverse. Alright, so we have h of s equals 4 to the 5 s. Alright, so we learned before. In order to find the inverse of the function, we need to replace h of s right here with y. Alright, so y equals 4 to the 5s right here. Alright, now next one, we need to swap s and y. So this guy turns out to be s, and then this guy turns out to be y. So 4 to the 5y right here. Okay, so next one, we look at the base right here. Alright, we see this is 4, and our goal is to find the inverse of this function. It turns out to be the log function, right? So we need to take log base for both sides because the base right here is 4. And remember that the exponential functions and the logarithmic functions, if they are inverse of each other, they must have the same base. Alright, so I'm going to take log base for both sides. So I have log base 4 right here, and this guy's log base 4. Now I just fill in this one. So it's s equals 4 to the 5y. Alright, so I'm going to apply the formula right here. Alright, for this guy right here. So what do I have? I have log base 4 of s, and I just rewrite. This one turns out to be 5y. Alright, now I need to solve for y. I divide both sides by 5. So I have y equals 1 over 5 log base 4 of s, right? And then this guy right here, I just replace y with h inverse of s equals 1 over 5 log base 4 of s. And this is the answer. Now let's move on to the next example. For example, if I have the function m of s equals 5 times log base 2 of s. Alright, so I need to find the inverse of this function. And given the logarithmic functions, the inverse must be exponential, right? So that is my goal. And you look at this one, the base right here, 2, right? So the exponential function must have the same base, right? So this is the base 2, alright? Now, we start from here. Alright, so we have this is ms, we just put this is y equals log base 2 of s, and this is 5 right here, right? Now we just swap s and y, so it's going to be s equals 5 log base 2 of y, right? So we look at this one, we see the number 5 in front of log, so we need to eliminate number 5 first. Alright, in order to do this one, I just bring this one back over here. I use the formula right here. Alright, so it turns out to be s equals log base 2 of y power of 5, like that, okay? The reason why, because I need to apply the first formula right here, right? I'm going to turn this one into the exponential both sides with the base 2. So I put the base 2 right here, the base 2 right here equals right here. Alright, so I put this one as exponent, right? As, and this guy as exponent. Log base 2 of y power of 5. Because the exponential function and the logarithmic functions have the same base. This is 2, this is base 2. I need to create base 2, okay? So, for the right hand side right here, I'm going to apply the first formula right here, this guy. So it turns out to be 2 to the s equals y to the 5th, right? Okay, now I need to solve for y. So I need to raise to the 1/5 both sides. So it's going to be 2 to the s all together power of 1 over 5. Alright, equals y, right? Because y power of 5 raised to the 1/5. And then 5 right here cancel out. The answer must be y. That's why we have this one. Alright, so this one I'm going to multiply the power. So it's going to be y equals 2 to the s over 5. Now I need to replace y right here with m inverse, right? So I have m inverse of s equals 2 to the s over 5. And that is the inverse function of the original function. Now let's move on to the next example. We need to find the inverse of this function right here. Alright, so this is the logarithmic functions. So our goal should be the exponential. Right? And then I see the base right here, 8. And then the base of exponential must be 8. Now I need to swap x and y, right? So I have x right here equals 1 4 log base 8 of y, right? And then what I'm going to do next is I need to eliminate 1 4 right here, right? So in order to apply the formula right here. Alright, so I need to multiply both sides by 4. So it turns out to be 4x equals log base 8 of y, right? And my goal should have the base 8 in the exponential function, right? So I need to take base 8 both sides, right? Of 4 to the s, and this is of log base 8 of y. Alright, now I need to apply the formula right here. So the left hand side should be a to the 4s, the right hand side should be y. So I need to rewrite this one as y equals a to the 4s. And then I need to replace y with f inverse, right, of s equals a to the 4s. And that is the answer for this question. Now let's move on to the next one. We need to find the inverse of these exponential functions. Alright, so this is exponential function with the base 10, right? So our goal is the logarithmic function, right? And then the base right here, 10, and then this guy must have base 10 right here, okay? So the first thing I need to do is I replace t of s with y, right? So y equals 10 to the 3 over 4s. Alright, next one, I need to swap s and y. So this guy is s, this guy 10 to the 3, 4, y. Alright, so now I see the base 10 right here, and I need to take log base 10 both sides, right? So I have log base 10, and this is log base 10. Alright, so I need to rewrite everything. So this is s, and this is 10 to the 3 over 4y. Alright, so for this guy right here, I need to apply the formula right here. Okay, so it turns out to be log base 10 of s equals 3 over 4y. Alright, so I'm going to multiply both sides by 4 over 3. So it turns out to be y equals 4 over 3 log base 10 of s. And we learned that log base 10, we just write log, right? So y equals 4 over 3 log s like this, okay? And we just replace y with t inverse of s equals 4 over 3 log s. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you're failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.